Okay, so as you've all heard, we are now recording. So welcome everyone to our weekly call. I'll just share my screen momentarily. Just a reminder of sort of the main focus for today. Where shortly I'll hand over to Brian in a moment from Cisco, Brian Summers, who's going to talk about DNSCrypt. As I put in my reminder email, the other encrypted DNS protocol. In fact, I think probably the longest standing of the protocols, albeit not currently an IETF standard, although I think that will come up in the discussion. And then I'll just give some brief reflections on the RSA conference from a couple of weeks back, and then, as always, touch on some sort of recent developments, forthcoming events, etc. And if time permits, we'll sort of just catch up on any other business, anything that anyone else wants to discuss. Okay, so that's the plan for the call, which hopefully won't come as a surprise to anyone. So let me just sort of welcome Brian onto the call. Brian gave a presentation on this topic at the OARC meeting, which seems like it was absolutely ages ago. It was only towards the end of February, so not so long ago, in Atlanta. I thought it was an interesting presentation, as DNSCrypt isn't or hasn't really been talked about much of late. So it was great to hear about that. And Brian has kindly agreed to maybe partly reprise and potentially update that presentation, and as always we'll have time for discussion as well, because I suspect there will be a few questions from people. So Brian, if I hand over to you, so the floor is yours to run through your material, and then if there are any sort of questions of clarification as we go along, people sort of use the Zoom tool to raise your hand or put something in the chat, and I'll draw attention to it. Otherwise, we have time for discussion at the end. So thanks for coming along, Brian, and over to you.
Okay, thanks, Andrew. Yeah, it's my pleasure to come along. The more people know about DNSCrypt, the better. As you said, this was already presented at OARC 40. There's a few updates to the words mostly, a couple of slides, one of which is this, which now says originally in front of it. I'll talk a little bit about DNSCrypt, the background, kind of what it does, what it doesn't do. I'll also talk about the fact that we're writing an RFC. The RFC is pretty much finished. We're just adding some code examples now because we have a running version at Cisco that has more than one implementation by implementations by two different teams. And I'll compare it with the related protocols, which of course are DO and DOT and DOQ to a certain extent. So at the moment, DNSCrypt uses version 2. So this is really kind of producing an RFC for version 3 of the protocol, and back referencing version 2 so that people can kind of I guess look at their software and make sure that it's compliant with version 2. Having said that, most of the protocol documentation has been taken from the DNSCrypt.info site, which has a huge amount of really good stuff on it. So I'd definitely suggest people go there if they're interested. And my favorite piece of the talk is really around DNSCrypt performance, and how badly we have done at Cisco with regard to performance, which I didn't find out until we actually looked at creating protocol version 3. So being a DNSCrypt background, so as Andrew said, it's the oldest of the DNS encryption protocols. It's been around since 2013. And it's been kind of known about by many vendors. A lot of people, things like Pi-hole use it as well. So it's been around for quite a while and is well known. But there's never been any kind of official standard, no RFC. the protocol was originally kind of established around taking the DNS payload and encrypting that, as opposed to changing the way that DNSCrypt works, which is really one of the big arguments against DO and DOT, but maybe not DLQ. The fact that their transport is TCP always is a kind of breaking the original idea behind DNS, which is to make it as fast as possible and have as little overhead as possible. Yeah, so I guess the idea behind DNSCrypt is to just make that change of protocol as little as possible. So in this conversation, I'll kind of talk a little bit about how DNS works. I'm sure everybody in the room is well aware of this. There's a client, there's a resolver, and there's a bunch of authoritative name servers. Sometimes there can be more than one resolver. We're really talking about the resolver that the client talks to. And we're specifically interested in this last mile, the kind of communication channel between the client and that first resolver. And that last mile is the thing that is unprotected and needs addressing. Yeah, so there's a number of other protocols around, as I'm sure people know. There's DNSSEC. DNSSEC, if I go back to the previous slide, is really about the conversation between the DNS resolver and the authoritative name servers. DNSSEC is a protocol to make sure, or to allow the resolver to validate the data that it's getting back from authoritative servers. It's not really geared up for use by the client. And the only real use by the client of DNSSEC is if the client has preloaded DNS keys that it wants to validate the traffic that it's receiving. But we're not going to talk much about that. We're really kind of geared up towards looking at that last mile and kind of how to protect that data path. So DNS over TLS, which is the kind of more raw of the two competing encryption protocols, is all about just taking DNS, always doing it over TCP, and TLS encrypting that TCP connection. It adds a little overhead due to TCP, because obviously the TCP to establish a TCP connection, you've got a bit of a handshake, and you've also got a TLS handshake. So there's a bit of overhead for DNS over TLS, but interestingly enough, which wasn't obvious to me at from the get-go, you actually make back a lot of that overhead by putting all of your queries, or many of your queries and many of your responses, in one packet that's being transmitted by TCP, because it's a stream-based protocol. They all get squished together and transmitted as part of the same packet. And you actually make or kind of recoup some of that TLS overhead because of this. The real problem with DNS over TLS is head-of-line blocking. If something happens, the TCP stream and a packet gets dropped, then until that packet is recovered, none of the subsequent data can be used, which means that one problem packet in the DNS stream will cause problems for subsequent packets as well. DNS over HTTPS is the same as DOT, except there's an HTTP layer in there. And the HTTP layer, again, seems like a bit of a funny idea when you first look at it, like, why do you need an HTTP layer? But actually the HTTP layer is HTTP2, and that gives you session management. And session management is kind of a bit awkward when you use DNS over TLS, because you have to do your own session management based on the DNS ID in the question in the query. DNS over HTTPS solves those problems, and it makes the whole session management thing a lot easier for the client. The server is a little bit more difficult because it has to deal with all the protocol stuff, but Yeah, that's. So there are a couple of upcoming equivalences to DOT and DOE, which is DNS over QUIC and DNS over HTTP3. HTTP3 uses QUIC, so they're equivalent to DOT and DOE. The nice thing about QUIC is that it's UDP based and it doesn't suffer from the head of line blocking issues, which sounds really, really attractive. I think the real problems with DOQ and DNS over HTTP3 at the moment is that the protocol is still fairly immature. And I've certainly heard some bad things about its performance. But we'll see. I have looking at this protocol high on my list for the coming years. So a little bit more about DNSCrypt. So DNSCrypt, the protocol, this is really how it works in a nutshell. So the idea is that if you look at the top right of that diagram, the resolver owner starts by generating a short-term key pair. Now this key pair is signed by a provider key. And DNSCrypt doesn't talk that much about how you generate and communicate that provider key. It's up to you to generate that provider key pair, store the secret key in a good place, and publish the public key so that all of your clients know it up front. The DNSCrypt proxy package that's distributed in the public domain has a whole bunch of provider keys already baked into it, so you configure it by just choosing your provider, and it does the rest for you. But anyway, the resolver generates a short-term key pair, and it publishes the short-term key pair as a part of the certificate that it publishes. And the certificate has a well-known name. So how the protocol works is that the client will download the certificate. It will generate its own short-term key pair. And basically, it will then use a Diffie-Hellman algorithm to take its private key and the server's public key and use that as a shared secret and encrypt traffic using that. And meanwhile, the server can take its private key and the client's public key, which is transmitted as part of the query, and use that to derive the same secret. And again, I'd invite people to read some of the RFCs about Diffie-Hellman key exchange to understand how that works, because it's quite a kind of interesting feature, but it's used in TLS, it's used everywhere. So the shared key is established on either side without transmitting the materials or all of the materials to derive that shared key. It's transmitted, or it's used to encrypt the query, and it's used to encrypt the response, so that nobody can decrypt the client's query except for the resolver, and nobody can decrypt the client's response except for the client. DNSCrypt, as it currently stands, is at Protocol 2, and that's what DNSCrypt.info, the website, talks about. And there's two kind of protocol sets in DNSCrypt version 2. They're essentially the same protocol sets. One uses Salsa rather than, one uses Cha-Cha-20 instead of Salsa 20. But apart from that kind of one line change to the protocol handling, that's the only change. It's the only variance in the protocol. So they're essentially the same. It's just Cha-Cha-2 is stronger in terms of hash generation. So DNSCrypt performance. So the idea behind DNSCrypt performance, and I mean, this is what all the published documentation says, is that it's very, very low overhead. So it's really cheap to do this, this encryption and decryption. So I originally kind of looked at this and thought, okay, well, what does cheap mean? I mean, that's cheap is in the eye of the beholder. Like, I don't really know what cheap means. Does cheap mean it's 10 times slower, or does it mean it's twice as fast, well, twice as slow, or like, what does cheap mean? I have no expectations. So anyway, I ran tests over the years, and this graph on the left is one of our graphs at Cisco that shows traffic turning up to a resolver, and the light blue piece represents the number of client queries that we're receiving. The dark blue represents the number of DNSCrypt client queries that we're receiving, and the yellow represents upstream queries. So what we're looking at is really a graph on the left that that shows that out of every 3 packets, 2 of them more or less are unencrypted, and 1 of them is encrypted using DNSCrypt. So it's quite a chunk of our traffic is being encrypted. And you can see on the right, so this other graph is a representation of how many queries upstream are required to satisfy the client request. And really what we're looking at here is the green stripe is 1 authoritative query upstream, and the light blue is 0 queries upstream. It's just being served from cache. So you can see that you know, predominantly this on this resolver for this snapshot, most of the queries are being served from cache. There's no upstream data involved, or queries or responses involved. So I had a look, and I was kind of curious as to, you know, exactly what does minimal overhead actually mean. So there's a program called perf on Linux that you can run that will essentially snapshot what your program is doing, what calls it's making. And those calls are not just function calls within your program itself, but it also delves down into library function calls and into system calls. So actually, you'll see kind of at the top of a lot of these spikes are kernel routines, and then as you kind of come down, you can see things like skb release, that's clearly a kernel function. skb kfree skb IP send, and then you've got things like sys send to. Well, that's the system call, the send to system call. So you can actually see a full representation of you know, the call stack, and you know, this urespond is one of our local functions within our resolver. So anyway, looking at the kind of interesting things, the things I was looking around for is the decryption routine, which is this DNSCrypt serve function, and the encrypt routine, which is this DNSCrypt one. And in fact, there's 2 different paths to get to encryption, because you can either encrypt the response coming from cache, or you can go off and you can do the whole DNS upstream shuffle, and eventually get an answer from that and end up serving it from a different place. So there's 2 places in our code that can serve responses, or that can encrypt responses. So I think the interesting thing about these about this code is that this this UNU is kind of, you know, the most interesting box, where we're basically receiving a query in UNU, so that's a new UDP packet, and we're then kind of doing something with that query. So of the stuff that we do with that query, for this whole length, this whole UNU length, a large portion of is this DNSCrypt decryption. And if I kind of zoom in on those, you can see this DNSCrypt uncurve and this DNSCrypt server curve. So that's the decrypt and encrypt functions. And the interesting thing here is that, whoops, I didn't mean to do that. This safe crypto box before NM, this before NM is actually the key derivation function, the function that takes the peer public key and our local private key and derives a shared secret. And this is kind of huge, because about 95% of the DNSCrypt server curve uncurve function is deriving a key. And all this stuff over here is the piece that actually does the decryption. And similarly, in this encrypt side of things, if you look at what we're actually doing in that encryption, it's almost all key derivation. And the piece that actually does the encryption is tiny. It's maybe 7%. So this got me thinking. So I looked into what we're actually doing with all of these materials. And it turns out that the resolver just receives a query. It caches the public key of the client. It derives the shared secret. It decrypts the traffic. And then it goes off and resolves it. And when it's finished resolving it, it derives the key again and sends the response back. And if you go to the DNSCrypt.info site, it says, well, you should really cache these materials. It doesn't really tell you why, but the why is quite clear here, that it's very expensive to actually do that key derivation. I'll just flip back there. So the interesting thing about this traffic is that when we originally measured our DNSCrypt traffic, that expectation about low overheads, well, actually an encrypted query took about 4 times the CPU that an unencrypted query did. And as I said, I wasn't sure if that was expected or not expected, or if that was low overhead or if that was high overhead. I didn't know. So I assumed it was low overhead and went on with my life. It turns out that if we just cache, or if we just cache the shared, the derived key from our queries and use that for our responses, we can actually decrease our used CPU on this machine by 20%, which really equates to changing that factor of 4, i.e. it's 4 times more costly to deal with encrypted packets than unencrypted packet. It changes that to 3. And that's before we've even introduced the caching. We're just reusing the same derived secret in that single query round trip rather than generating it twice. So we're making progress, but of course we still haven't got to the bottom of it, or got to the end of it. So anyway, in my last 20 seconds, I'll just talk quickly about DNSCrypt version 3. So DNSCrypt version 3 is really all about FedRAMP support. Cisco is getting involved with FedRAMP. FedRAMP is a government program in the US for complying to encryption standards that allows you to sell to government agencies and other people that care about security, I guess. I won't go into my opinions about FIPS, but FIPS is what it is. So what we've done is we've invented a DNSCrypt version 3 extension, and this version 3 extension is just using a different algorithm set. It's using a different algorithm set because these algorithms are FIPS compliant. I won't go into whether they should be FIPS compliant, because in my opinion, the original algorithm set, which uses EC25519, is as good as these algorithms. The interesting difference about this algorithm set is that it uses P256 encryption, which is an elliptic curve as well, but it has a key length of 33 rather than 32. So it upsets enough things in the protocol that we invented this new version of the protocol to allow it to be handled. And really the only 2 things that we're kind of addressing or changing is the way the padding works and the way certificate renewal works. Padding is all about, so version 2 has a claim that it prevents amplification attacks, but the way it prevents amplification attacks is by insisting that the client pads its traffic so that it's bigger than the response, which in our experiments has just led to the client always using 1300 byte packets as queries, which is not really a way of dealing with amplification attacks. It's just increasing your query sizes. And then the second is a little bit more definition around certificate renewal and when you should do that as a client. I have a bunch of references here. I can share the slides if people are interested, and that's really all I've got. So I'm open to questions if anybody has any. Or
Brian, do you just want to mention your or your thoughts on standardization of the DNSCrypt?
yeah, absolutely. I guess I kind of skipped over that pretty quickly, didn't I? I didn't even find the slide that talks about it. I guess it's only talked about here. So we have been working in an RFC. It'll be an informational RFC because it's kind of a little bit after the fact, but there are a lot of vendors that already use DNSCrypt. Quad9 is one of them. Cisco is one of them. There's a ton more. So the RFC really talks about specifically protocol version 2. Well, it's specifically protocol version 3, and then it calls out where this differs from version 2. And all of the materials that it's based this on are available on DNSCrypt.info, which is an excellent site, as I kind of mentioned before. But we haven't actually communicated or shared the RFC with anybody yet. But we're at the point now, as I said, we've got implementations. We have a section in the RFC in the appendix around code examples for how to actually perform the encryption, the decryption, the signature verification, and the signing. And once we've added those in, we'll start sharing this with the IETF and figuring out how to get the ball rolling with respect to publishing the RFC.
Do you have a view on which working group to land this with? Or have you not got far yet, which would be fine.
I don't at the moment. I kind of assumed that the IETF was the right way to go, but I don't know.
Within the IETF, if you've got as far as thinking about that, but no issue if you've not thought that far ahead yet.
Yeah, I have an item on my list that literally says, find out how to do this.
Fair enough. Well, there may be a few people on here that might have a view on that then.
Yeah, I'm all ears. It would be very welcome, in fact.
Perfect. Okay, well, thank you for that. So if anyone has any questions, either just sort of raise your virtual hand and unmute, or if it's easier, put anything in the chat. Be interesting to see if anyone's got any thoughts or comments. Give you a chance to think about that. Oh, and I see, Benno has helpfully put a link to the draft by the look of it, judging by the title. DNSCrypt draft. Is that the draft RFC?
This looks like Frank Dennis. The fact that it has Dennis in it. That's kind of interesting. Updated. No, this isn't the one that we're working on at all. But I did communicate with Frank Dennis around what our plans were. So maybe he already had work in progress. This is kind of interesting.
Yeah, I've just clicked on that link and it tells me it's an informational draft dated the 9th of March. So I can see, Arno, you've got your hand raised. Did you want to come in?
Yes, thank you, and hi, everyone. So yeah, I find it really interesting presentation. Just for my own education, it's the first time I see a flame graphic. I had difficulties. First of all, I'm colorblind, so that doesn't help. But if you could help me understand better how to read the flame diagram, if you could come back on that slide.
Certainly. Let me just find that again. Yeah, sure. I definitely suggest that reading up on the command is, or the graph is generated by a program called perf. And that program generates a SVG file in the end. The SVG file can be quite large, depending on how many samples that you take. but it can then be just looked at in your browser. And it's quite cool because you can kind of go to any of these things and just click on them, and it will give you a zoom in on that. So you can see these are zoom ins where it grays out all of the things beneath it and just shows you that stack from there on. But the way you'd read this is you start off with Open DNS Cache, that's a process name, and the original stack has the whole machine. So perf will measure all of the functions being called by all of the programs on your machine. So here I've just zoomed in on Open DNS Cache, but the first thing that most programs will call is start thread, and then DNS cache start routine is our worker thread routine, and then we've got a whole bunch of conf workers. So as you go kind of north or up in the stack, you see that each function or system call has a bunch of kind of things that it does that are measured on the stack. And then each one of those things has a number of things that it does. So you can really kind of see how much time any given function spends waiting on another function to complete. So, going from the bottom here, Open DNS Cache calls clone, and it's, well, I guess it's a zoom in, so it's not very interesting, but start thread really has two things to do. It calls conf worker and it calls DNS cache start routine. So that gives you an idea about how much of our resolver is spent loading configuration. That looks like about maybe 12% versus actually resolving DNS queries. It doesn't give you much of a picture as to how many CPUs are being used on a multi-CPU box, but it consolidates all of that data into one. So, for example, on this box, I think I was running about 23 worker threads and about 10 conf workers. So those proportions are kind of the cumulative addition of those 23 worker threads, and the 10 conf threads are kind of added up and shown in the kind of stack on the left.
I see. So if I, sorry for my very basic questions how to read it, but the x-axis represents the entire workload, if I may, and then conf work would be like a small portion versus DNS cache start routine. Is this how to read it, or?
Yeah, absolutely. That's correct.
So then my question is, because what you say, so for example, when I look at DNSCrypt serve and the other one, they look very small there, but actually this is where you found that there was a lot of time consumed. So I was a bit confused how you figured out that these were really where the entire system spent a lot of time.
Yeah, so I can kind of give that a little bit more color. So in our code, so that worker thread is this DNS cache start routine, and FD event dispatch is where we run epoll on a series of descriptors. So those file descriptors are all of the clients that are currently in business with us, and all of the authoritative servers that we're currently talking to. So our epoll descriptor set is just looking at that and kind of saying, okay, well, which of those descriptors are ready and what do I have to process? And this part here, this FD event wait is, well, we're actually just waiting. So spending lots of time in FD event wait is basically idle CPU.
Okay.
So really the program is doing FD event dispatch, and that's all it does. It's its entire job. There's a few kind of small things over here, but they're pretty much irrelevant to this conversation. And that FD event dispatch is really about new incoming DNS queries. So that new function is called when it gets a new query. And the other side of it is you respond, and that's where it received something from the authoritative server and it now has an answer to serve to a client. And then this kind of third piece is where it receives a response from an authoritative server, and it's got more authoritative queries to send. So, you have to have kind of some knowledge about what you expect.
What the thing is doing. And now I understand the logic. So this is how you figured out where the system is spending time.
Yeah, so I was kind of interested in where DNSCrypt, the DNSCrypt functions were in the stack, but also how much of the kind of x-axis it used in its calling function. So here you can see new is the thing responsible for dealing with a new incoming UDP query. And the fact that it spent this kind of amount of time wasn't necessarily surprising to me, because I didn't really have any expectations around what this was. This is the processing, this is the decryption of the query, this is the processing of the query, and this is sending the response. So yeah, okay, that looks fine. But then the zoom in was the thing that raised my eyebrows, because when I zoom in on this, if I go back to the previous slide, you can't really kind of see.
No.
It's getting hard to see there. So zooming in on this shows me that actually 95% of my time is being spent in this before an end function. And that's the thing that generates this shared secret, this derived secret.
I see, okay.
And that derived secret is something that we can cache, and in fact our DNSCrypt.info can cache it.
Interesting. Okay, thank you very much. Sorry for wasting people's time if this is obvious, but that was really not.
No, it's not a waste of time.
Thank you.
Thanks for that. No, thanks for the explanation, Brian. That was helpful. Josh has put in the chat about any thoughts on working with the ADD working group, and has put, for example, the DDR, which is one of the discovery protocols for discovery of encrypted resolvers. Josh, interrupt me, sort of unmute if I'm guessing incorrectly on the point you're making, in terms of if that's a suggestion where the DNSCrypt RFC could land. I don't think it could land there, because the purpose of that working group, the charter, is on discovery of resolvers. It's got quite a tight charter.
Right. Sorry. So I'll apologize for some of the background noise. It may not be appropriate to the current discussion. It's more of a curiosity that we have a lot of different protocols, different options when it comes to encrypted DNS.
Yeah.
And currently, almost all of them, I think all of them actually now, it's built into the client. Which resolver is used is either manually selected or built into the client. And I'm just wondering if DNSCrypt will sort of provide a way for the client to discover, or more in a more native way, to dynamically seek out the best resolver.
Yeah, absolutely. I think, in terms of DDR, I like the DDR protocol. For anybody who's not aware of it, it's DDR is where you teach the resolver to respond to certain queries. So _DNS.resolver.arpa. And if you query for SVCB records, it will give you alternate versions of the same service as the response. So one RR in the RR set for each alternate service. So there are definitions for DOT. There's a definition for DO, but it's kind of missing a key around the path for the DO path. And it could certainly also, we could standardize a set of keys that could describe DNSCrypt. So the idea behind it is that you use DDR to find equivalent services, and then you choose which one you want. The server can give you kind of weighting or priorities on those records as well. The tricky thing about DDR versus DNSCrypt is that the DDR service that's published is expected to have a TLS certificate that has a subject alternate name of the original service that you came from, just to make sure that everybody agrees that this is the same service. And DNSCrypt doesn't have a way of providing subject alternate names. So we'll have to have a way of doing that. And I'm not sure how that will work yet.
It certainly would be a good thing to build in support for discovery, whether it's DDR or in fact DNR, for that matter. That will sort of future-proof it, I guess, and encourage more take-up. But it sounds like, yeah, it's on your radar anyway, yeah, Brian, giving your response, which is a good thing.
Yeah, very definitely.
Okay, good. Anyone else got any questions? Just looking at the chat, see if there are any hands raised. I can see positive comments from others who've found the explanations useful, so that's encouraging. I can't remember if it was on your slide, Brian. If anyone wants to follow up perhaps with you directly, which they may well do, are your contact details on were they on either your start or end slide, or by any chance?
I think I had them at the start, so yeah, not very good contact details. You can definitely Google me, but yeah, I can provide that in the chat.
Perfect. And as you said, if you're happy to share the slides, if you send them to me, I'll be happy to sort of put them on the mailing list to people to peruse at their leisure as well, which would be
okay. Yeah, that's the best approach. I'll share the slides with you, and you can share the details with the slides, maybe.
Yeah, surely. Fantastic. Okay, well, if there are no more questions, we'll move on there. Just seeing, I can't see anything else. I can't see any hands raised. So thank you, Brian. That's really helpful. So appreciate running through that, and it's good to know that sort of DNSCrypt will be added to the standardised encrypted DNS options alongside the others, which is good to see. Okay, well, we'll move on there. So, Brian, you're welcome to stay or to go, whichever, depending on how busy you are. You're very welcome to stay on the call, but I will move on. So let me reshare my screen. Okay, as I mentioned at the start, I'm just going to give some brief reflections on the RSAC, the RSA conference from a couple of weeks back. Firstly, San Francisco was very warm, which was quite lucky, I think, for the time of year. It was a very pleasant and dry weather for the whole week, which in the spring is quite unusual. A couple of days where there's a bit of fog, but that burned off early morning. So it was sort of very nice to be there for the week. Just some, and these are very brief impressions. Happily have a more detailed conversation with anyone that's interested offline. It's a very big conference. I'm not sure what the pre-COVID numbers for the RSA conferences would be, but I think I heard from the organisers there was slightly above 40,000 attendees on site. In San Francisco, so an awful lot of people spread across the sort of various parts of the conference facilities. So compared, for example, to an IETF meeting, it was about 40 times the size as a sort of a rough benchmark. One of the topics that came up very early on in the week was there was a panel with 4 of the sort of 5 eyes sort of represented, and they all agreed that by far and away the biggest threat that they see collectively at the moment is ransomware, and that is the focus of a 37 country grouping that's been pulled together to try and counter the effects of ransomware. So various government agencies from 37 countries currently paying a lot of attention to that. So I thought you might be interested to know that was the case. In various of the fora that I attended, I did ask various CISOs and standards, and standard development is to generalize, is not on their collective radar. So stuff that's done in the standards development organizations isn't something that CISOs collectively are tracking. There may be the odd one or two exceptions, but unsurprisingly, they're very focused on operational matters as opposed to stuff that is under development. And then the other topic which came up a few times was about the projected impact of quantum computing and the need for post-quantum encryption, etc. And as has been said in other fora, I think the received wisdom is we've got sort of 10 years plus to deal with that. Although there is part of me which does sort of wonder if an intelligence agency or other group has cracked quantum computing, they probably wouldn't go around shouting about it. So we probably wouldn't know until sometime afterwards that they actually had a viable solution. But as I say, the received wisdom is that that's sort of 10 years or so away. And then just the other thing, quite a fun finale with some invited speakers, one of which was Christopher Lloyd, as you can see on my screen, with I chat to him about his sort of various roles, including inevitably Back to the Future. And as you can see, they had one of the DeLorean fleet from one of the various films as one of the props that they had on site, as well as talking to the man himself, which was quite good fun. So overall, a very interesting event, but as I say, ransomware is perceived as the key threat, and post-quantum is of concern, but not for the next decade, roughly. So that's my probably about 2-minute summary of a very large-scale event. But as I say, happy to chat offline to anyone that has any specific questions on any of that. In terms of just moving on then to news headlines, nothing really major from the last week or so. You would have seen these in the weekly email, sort of various bits and pieces, but nothing that really grabbed my attention. I mean, you can take your pick from the things on the screen. Yeah, a few interesting reports. Probably worth a look at the Internet Society's take on encrypted DNS, for example, and the article on CISO Online about some of the challenges posed by encrypted DNS to enterprises, but so nothing really especially attention grabbing, if I'm honest, from the week. Yeah, you can also see the sort of DNS filters take on the conference day, and many other software vendors, unsurprisingly, were at the event in force. So definitely worth just looking at some of those sort of various bits and pieces. But as I say, nothing really major on the news headlines from the last couple of weeks, if I'm honest. A reminder, some deadlines coming up in the next 2-3 weeks. So in fact, a couple of days' time, if you had an ambition to present any papers for the Implied Networking Research Workshop, then that deadline's in 2 days' time. And as many of you will know, those papers are presented at the IETF event. So sort of two days before the deadline. Also, in just over a week's time, you've got the Internet Governance Forum, IGF 2023, call for session proposals. That deadline is on the 19th of May. So obviously much more on the policy rather than the technical side in terms of the IGF, which takes place in Kyoto in October. Okay, and then just a reminder, we got I think the next event that's coming up in a couple of days' time is the Google annual Google I/O event, and then before we know it, it will be time for RIPE, starting with the DNS hackathon on the 20th and 21st of May, and so on. So various things sort of running on. Oh, it's also just whilst it's on my mind, if you've not seen it, the registration is opened for the next IETF meeting, which is also taking place in San Francisco at the end of July. So registration is open for that at the early bird rate. So since the registration rates have all gone up, probably all the more reason to take advantage of the early bird rate if you're planning to go. I'm pretty sure. Oh no, and then looking ahead on this call next week, we're going to have a sort of a mini panel talking about demands for mandatory DNS filtering, whether that's a cause for concern or not. The following week, a couple of the team from Echo will come along to talk about the top DNS project, which is focused on DNS abuse. And then beginning of June, we got Neil Cook from the DNS, from the Open Exchange team. We'll talk about the latest update on DNSDist, which supports encrypted DNS on CPE. And also Peter Lowe will join us to talk about his recent paper, The Joy of Text, which we touched on briefly on this call a couple of weeks ago. Okay, so that I think is everything from me. So in the last few minutes, just I'll pause to see if anyone had any comments or questions. Answering Arno's comment in the chat, yes, CISOs and standards, just to reiterate that was one of the things I said on the RSAC event. It was just an observation that the CISOs that I spoke to, or where I raised the question in various events, just confirmed to me that they weren't really focused on or aware of standards developments. If it wasn't operational, it wasn't on their radar, which isn't to say it shouldn't be, just that it's not something that if the vast majority of them seem to be conscious of just now. So they would need persuasion. I mean, oh no, you're probably far more aware of this than I am, to be fair, from your own conversations. So it won't come as a surprise to you. But just I thought I made a point of asking where I had the opportunity whether anyone was tracking standards development, and in broad terms, the answer was no, not really, not in any meaningful sense.
So okay, indeed, no surprise, because when I saw that on your bullet point, I said, oh, maybe there is a good news. So just so that you know, in the ITU, I was extraordinarily put under pressure the past 2 weeks on the TSAG level, especially on what is called industrial engagement. And that's exactly the issue that you are discussing now.
Okay.
So the idea would be to create a CXO level workshop in 2024 to find a way to attract the CEOs and CISOs and others into a meeting where we could discuss, let's say, interoperability in the broad world, but because a lot are complaining about vendor lock-in and hyper-regionalization and fragmentation, and so it starts to arrive to their agenda, but they still don't recognize that one key element of all of that is standardization. So therefore, attracting them with this, the idea is to tell them, so what's wrong with standardization? What is it? And get their feedback so that the people who are doing standardization start to realize, especially member states in the ITU would understand, that's where the problem is. Okay, not me telling them, but the real people telling them.
Yes, yeah, absolutely. So as I say, unfortunately, not a pleasant surprise for you there, but anyway, which does remind me.
Good intention.
Well, yeah, exactly. Probably the one other thing I will mention very briefly, conscious we're just about out of time, is I joined the European Commission's high-level group for internet governance call a couple of weeks ago. One of the topics on that call was the DNS4 EU Resolver project, and it was mentioned that they're sort of pivoting slightly, or broadening the scope, as would be a better phrase, to look at protective DNS proposals for governments. So this is really to broaden the scope of what DNS4EU does to incorporate a protective DNS offering that they can pitch to the governments of member states. I presume, although it wasn't discussed on the call, to provide some revenue generation opportunities to help fund the operation of the overall Resolver project. So that just came up in an update on the DNS4EU element. Again, if anyone's interested in that, just reach out to me directly. Okay, we're pretty much out of time, just a minute after the hour. So let's sort of draw the call to a close then. Thank you again, Brian, for joining us. That's very much appreciated. And I'll share Brian's slides post-call. So please follow up directly with Brian if you've got any sort of questions on that. And I guess also if you've got any suggestions for Brian as to where in the IETF would be a good place to land the proposal. Anyone's got any thoughts on that? I know there's a few working group chairs and others on this call, so I'm sure guidance would be appreciated if you have any thoughts on that. But other than that, thanks everyone for your time. Have a fantastic week, and look forward to catching up same time next week. So speak to you all then. Bye everyone.